close my webcam. Okay, we do the same thing. As I said, laptop, Google Classroom, and I will use the Google Meet now. Okay, so we will continue now. If there's no questions from anyone at home, any questions, those at home? Okay, I will just open the last section also. Chapter 2 to be finished already. To be finished. Okay, I see some of them know the at least got some physical reply compared to totally. Okay. So let me open the notes there. So we are supposed to do chapter 3 to be finished, completely finished. So I won't do recap again. I straight go to B. Chapter 3. Okay. So I will close my webcam. I will do the video recording. Okay, now everything will be back to as usual. I think this week 5, I'm sure you know there's one quiz at week 7. So once I get the confirmation from our course coordinator, I will post in the Google Classroom week 7, most likely the quiz, which will be testing on chapter 1, 2, and 3. Unless there's changes, I will inform everyone. Okay. So I will start now. You can see this is chapter 3. I don't use the projector for those that DK here. I hope you all have your own laptop. If you have your earphone, use your earphone so that you can listen better, and also do not interrupt people sitting beside you. Okay, you can see my screen there is probability. I'm sure everyone already know what is that probability. You have heard before, at least the word probability. Okay, those of you who have taken statistics subjects before, right? Probability is actually very subjective. And some people heard that when they heard of probability, some of the friends say, well, probability very scary one because it's very subjective. Not easy to calculate probability. Because first, one person must understand the idea, the concept of probability. Okay. Now, in probability, experiment is defined as a process which generates a well-defined outcome. So when we talk about probability, the first thing is we talk about outcomes. In Bahasa Malaysia, we call it how do you call Bahasa Malaysia? Kemarin kalian, or we call it kemungkinan. I'm sure you're well versed with Bahasa Malaysia. Okay, you know Mandarin, right? Mandarin. So that's not predictable. We cannot predict one. Predict means we cannot determine in advance. For example, I ask you all, what's the chances this afternoon will rain? So far, these few days, afternoon wind, right, very heavy. So today, we are not sure whether it will rain also, right? So if I ask you, can we predict or how much we can predict this afternoon will rain also? We don't know. So there's an outcome, a well-defined outcome, which cannot be predicted in advance. So that's called experiment. The idea, the general idea of probability. We talk about sample space here. When we write down all the possible outcomes of all the experiment, we have defined the sample space. Now, first thing, when you learn probability, the first terms, the first word you have to take note is called sample space. Now, give you an example. The possible outcomes which we use the symbol of S. S means sample space. So on and off, when we do the discussion in tutorial or example, you can see that the writer will use the symbol S. So that means it's all the possible outcome. For example, okay, now I start with this one, throw a coin. Everybody take a coin right before, and then when you throw the coin, you can see two sample space, right? What are they? Either you get head or tail. This is called outcome, right? Unless your coin is different. And then you throw two coins. Now you throw two coins, then you can have both also show the head. Imagine both coins show the head, or one head, one tail. One tail, one head, or both also tail. And, so you see, if you throw one coin, you have head and tail, only two possible outcomes. But if you throw two coins out, what happens? You get four possible outcomes. That is double already. If you throw three coins, what happens? 8, right? 2 power 3. Can you imagine how to write the 8 possible outcome? Everybody, you can write down on your poster. Okay, rolling a dice, another example. Everybody know what it's called dadu, right? The dice. When you throw one die, your die can show you 1, 2, 3, 4, 5, 6 up. That is the normal outcome, which everybody already know that. If you throw 2 dice, then what happens? How many outcomes you can have? You see here, a pair of dice. This is what you get, 36, right? 6 times 6, 36, which is the first number is the first die. The second number is the second die. So you see, the first die can be 1, 1. Second die also 1, sorry. First die 1, second die 2, then 1 and 3 and so on. Repeat. After that, the first die can be 2, second die 1, then 2, 2, and so on. Repeat until first die 6, second die 1, and up to the both also 6, 6. So 36. If I throw 3 dice, what happens? Getting bigger, right? The outcome. So this is a simple example that can help a person to understand. When we do one experiment, you can have a list of outcome, and all this list of outcome is called sample space. Yeah. Okay. The next word that you have to take note is called event. Event is actually, after we know all these outcomes, right, for one experiment, and then when we have a set of outcomes, you all know what's called set of outcomes, right, which satisfy a given condition. Now here, we call this condition, in Bahasa Malaysia, we call it syarat. In Mandarin, you know what to call, right? Okay, which means there is a condition set before one event can happen. For example, the event is said to have occurred if the outcome of the experiment is contained in the event set. Okay, let's say I throw a die. This is the possible event. When I talk about possible event, I talk about what? Condition. So, for example, when I throw a die, remember I can get 1, 2, 3, 4, 5, 6, right? 6 outcomes, but I don't know which number. So when I give a condition, when I set a condition, I must get, let's say example, the die show that it is a 5 number. That is a condition, which means I call this event A. I can name any event, event A, event B, or event P or Q, doesn't matter, just name an event. And the condition is to obtain 5. All right, understand? Now, another example, I want to get even number. This is a condition, right? So what's the even number when you throw a die? You can possible to have it 2, 4, and 6. Any other number? No, right? Unless your die is very special one. Okay, so you have 2, 4, and 6. So this is the condition. So you name it event B. All right? And let's look at one more example. Now you toss 2 coins. These are the experiment. So Remember, when you throw two coins, you can have HH, HT, TH, and both also tail, right? But when I set the condition, let's say getting at least one head, what's the meaning at least of? What's the measure called sekurang-kurangnya, right? In Mandarin, we call it what we call okay. So if you look at the result that we have, is head, tail, head, and both also head. Am I right? Here. Why? Because at least one head, man. One head means there must be one H there, or two H. That's called at least one. At least means minimum. Minimum, all right? So we have one head or both also head. So this is the condition we set, and we call this event C. Understand? Yeah. All right, now event D. Event D, let's say we want to get exactly one head. Exactly one head means you only have one head. Cannot be have two heads or no H. So exactly one head. From these four outcomes, you can have this one and exactly one head. HT or TH. It doesn't matter which die got head. Okay, it can be first die or second die. As long as only one head. But some questions say exactly one head, unless they add in extra condition. Add in extra condition means the first we get head. What does that mean? You only can have H and T already. That means the second one TH cannot, because they say first die is head. So when the more condition impose, the outcome getting lesser and lesser, more precise. So this is called, let's say, event D. Any questions so far? All right. Now another example, we demand for a new product. Let's say handphone want to produce in the factory today. So we want to ask for more than eight handphone in the factory. So what is the number that more than 8 in our real number? Our number can be 0 to millions, right? So here from more than 8 means 9, 10, 11 up to 8. Now you all know this symbol, right? Anyone ever seen this symbol before? It's called infinity. Of infinity. There can be millions of. So we call this event E. Alright, everybody clear? I move on. If you have any questions, those in the house one, you can also what do you call that? What's up in your chat box? Okay, now I will go straight to Venn diagram now. Okay, I'm sure everyone have seen this before. Venn diagram is like a set. Okay, when we talk about probability, a lot of times the event experiment, okay, is pictured in Venn diagram. We call this Venn diagram. I'm not sure how many of you remember this word now. If you haven't seen before, so never mind. You can find from any textbook. Okay. Now it's like a simple square, and inside here, usually we picture or we illustrate the events as a circle. Okay. Now, basically, it's a simple pictorial present the relationship between the events. So you can see that outside the box here, we have a space symbol, and the circle represent the events. Now, here, of course, depends on if you have one event, you have one circle. If you have two events, you have two circles. Three events, three circles, and so on. Okay. Now, maximum, I can say that usually up to 3. Right? Even 3 events can be very complicated already. Okay, I can see some question testing up to a very high level. Usually 2 events are two circles. Right? So you can see some of the question later on how we solve using Venn diagram. Okay. Now I hope everyone already up to here understand the experiment and also the sample space event also. So we go straight to complement of an event now. Okay. What is called complement? What does that mean? Actually, it's an event that does not occur, which means if I have an event A, let's say you see the circle shown by the arrow, right? Whatever does not happen in the event or does not occur in the circle, which is the event A, is called A bar. See the symbol A bar? On top there's one score line there. This is called A bar. So I repeat, what is called complement? It is an event that those happening does not occur in the event A itself. And it contains all the experimental outcome. It means that it contains all the experimental outcome that are not contained in the event A. So you highlight here, not happen in the event A. Either A or A bar is certain to occur when the experiment is carried out, as both events together contain all the outcomes in the sample space. Meaning that when I have a A bar and the A together, all will combine the outcomes in the sample space. Now remember, the square box is a sample space, right? Whatever happened in A and not happen in the A, which is A bar, when you combine them together, it represents what? All the outcomes in the sample space. Which means, I write here, probability. Today I don't bring my digital pen, sorry, I have to use my mouse to write. Okay, I hope you can see that a bit slower. Okay, PA bar, sorry, P stands for what? Probability of the event A bar, which is the complement. You plus because you combine with the probability of the happening in the event A, or we call it set A, and equal to what? Can someone tell me? Some of you still remember the whole sample space probability here is always equal to 100%. Cham Kim Yen say 1. I see some of you say 1. Yes, correct. The answer is 1, which represents all the outcomes. So this is the formula I need you to remember. Example, okay? If I have a probability of A is, let's say, 0.4. This here. What's the probability of A bar? 0.6. How we do? 1 minus 0.4. Understand? As long as total must equal to 1. If I have the probability of girls is 70%, what's the probability of boys? 30%, no? If I have the probability of pass 80%, so what's the probability of fail? 20%, no? Yeah. All right. So this is the first thing you have to look. Okay. The second, we call it terms on that you have to take note is called union of events. When we talk about union, I'm sure those of you who learn set up. In fact, everyone should have done this before. Set. Let's call it set A and set B. Represent the event A and event B. The union. Union means what? We shade all the circle A to B, right? Which means we cover everything. And this is the symbol we use. Union. You can go back to your set subjects last time, topics. So it means that the A and B belong to either set A or B, or belong either to set B or both, both A and B. Okay, so you take note of this symbol first. Later, we are going to look at the formula. There is a formula which you have to calculate the probability. So remember, everyone, I introduced just P stand for what? Probability. This topic of probability now. Okay. Now, the third types of events that you have to take note when we play around with Venn diagram is called intersection. I'm sure these are also nothing new. The symbol we use is something like an N. What does this mean? Let's say you have two events A and B. Okay, define the sample space again in the square box. So the intersection of A and B, which means that the middle part here, the shaded one is the middle one, okay, which means the belong to A and also belong to B, which means satisfy A and satisfy B. It cannot just satisfy A only or just satisfy B only. It must satisfy both. And you can see that the outside one that is not satisfied. Okay, so same for the A union B. A union B means you can take all, but intersection only the middle part. So later we are going to see the formula. When you calculate, make sure you understand intersection and union. Okay. Now I introduce the formally now. The P, as I mentioned just now, is probability. Okay. Now the first question I asked just now, right? What is probability? Most of you have heard before, even in Barcelona or Mandarin or whatever. But the formal definition of probability is actually called the likelihood. What's the meaning likelihood? The chances. Likelihood means not going to happen exactly. Maybe. I use the word maybe. Like I ask you, is it going to rain this afternoon? You also don't know. I also don't know. So maybe, maybe not. So that's called likelihood. Chances. When we talk about chances, we talk about what percentage, right? Maybe 50% rain or 70% very high chance to rain this afternoon. Possibility. Another word is called possibility. And proportion. Proportion is the percentage. So all these are actually the same meaning one, even though different words. Okay. So this is actually the definition for probability. Now, because of the likelihood, the chances is uncertain, right? Not predictable. We cannot be sure one. Like I ask you next week, how many of you will come? You also don't know. I also don't know. So we cannot predict. Because of that, so when you want to calculate probability, not easy. For example, you ask how many chances the team will win the football game or badminton. We don't know. Right? Uncertain. Unless we can predict that we are something, we are not human being. So because of that, it's very difficult to calculate probability. But we have these events like intersection, union, complement, and later we talk about condition probability. These are few formula that can help us to calculate for exam purpose. Okay, we will do that also in our tutorial. Now, next example of fact statements of probability. Let's say there is a 30% chance. 30% chance means what? P equal to. Can you tell me what's the P? 0.3. 0.3. Now, remember probability cannot be more than 1. Probability maximum is 100%. 100% means 1. 30% means 0.3. There is no possibility of delivering the goods before Tuesday. What does that mean? It means that no possibility means the P equal to 0. Yes, probability can be 0. It can be 0, but cannot be more than 1. Alright, so this is the notation we use. P type of probability. A is the event now. Okay. Now, the sum of the probabilities of all possible outcomes must be 1. Doesn't matter whether you have 1 circle or 2 circle or 3 circle, as long as all the probabilities in the event, A or B or C, altogether must equal to 1. And that will give us Bayes' theorem after this. Alright, so you can see this, as I mentioned just now, 90% chance means 0.9. Understood that the outcome A will happen. Then it will also imply that there's a 10%. If 90% outcome A happen, that means 10% or 0.1 A will not happen. Which means 30% boys, 70% girls. Okay. Now the total probability of A and A not happen must equal to 1, which I mentioned here just now. Okay. Now, in statistics, probabilities are commonly expressed as proportion and not percentage. Alright. Now, some people ask, when you solve the question, do we have to write in percentage or write in proportions? Proportions is a point form. Let's say 0.1. When you times 100, it becomes 10%. Right? So that's the difference between proportion and percentage. So I just clarify here. When you do a tutorial or exam, your probability must write in point form. Proportion. Don't write in percentage. Even though I know it's correct. Okay. Lastly, as I mentioned, the smallest value for all probability is 0, and which means impossible to happen, and the largest is 1. So this is the condition that you all must remember. You see the equal sign here? Can be 0, can be 1. Now I want to clarify here, because when we do marking, many times we see the student answer. I did see some student answer, let's say, example, 1.8, 2.25, the probability they calculate. What does this mean? Totally wrong, right? How can be probability 1.8 or 2.25? When you calculate the probability, tutorial whatever, you see that your answer more than 1, what should you do? It's already wrong. Can you go and check where's the mistake? I see some people don't care one, they just write the answer. Negative 0.3 also got. Probability cannot be negative. This is what I want to stress here. Okay, right. Now, this part, classical probability, is actually the story that how we come up with this formula, the general formula to calculate probability of an event. Basically, we take the total number of outcomes which constitute the event, divide by all the possible outcomes. So that will give us the formula to calculate the probability of certain A event. This is the formula. N means the number of that A event divided by the N, which is the number of sample space. Remember that all the possible outcomes are in the sample space. Okay. So you can read here, NS is the possible outcomes, the total. AN is the number of outcomes that happen in the event here. Okay, example, let's say you throw a fair die again. Remember, you can have 1, 2, 3, 4, 5, 6 possible outcomes. And then let's say the event E, you name the event E is the getting odd number. Getting odd number from a die is which number? 1, 3, and 5. Right, 1, 3, and 5. So let's say the sample space is 1, 2, 3, 4, 5, 6, NS is 6 1. NE is what? 3 because 1, 3, 5 odd number. So how to find the probability of E event is how we write down. So we take NE divided by NS. In this case, E is our A event of the specific event. So we have 3 over 6 we have. Any questions? I think everybody know already, right? How to find probability. But the formal definition is this one now. So let's say another example. Find the PF. F is the event you get more than 4. Throwing a die. What number more than 4? 5 and 6 only, right? So we have let's say an F. We call this event F. We have 2 only. Then the probability to get F is 2 over 6. 1 over 3. Okay? So list down your sample space correctly here. Right. Okay, now the next one, relative frequency concept. I'm sure in chapter 2 and 2b, everybody still remember the frequency table, right? When we talk about frequency. So in this statistics calculating probability, we also can use a frequency table. You can see here. It is based on relative. Relative means based on the number. Okay. Now you can see, let's say, another way the question asks in the frequency table is, let's say, 350 families, and then they record how many children below 16 years old for that particular family. So 0, 1, 2, 3 or more. Okay, which is below 16, and then this is the frequency to record the family stuff. So based on this table, you can see sometimes the question asks in table 1, don't panic, because we find that some students in the test or quiz, when they see this type of question in the table form, they start to panic already, because they always thought to have this type of questions. Suddenly become like this, then they don't know how to find already. So let's say find the probability that event A, let's call the event A, no children. How to find the probability of the families with no children? So you look at here, no children, 185 divided by 350. Okay, remember? Always divide by the total. So you simplify, you will get this one. So you write down here PA. Okay, everyone. I have some difficulties to write here, so I hope everybody can bear with it. Now, B, event family selected has at least 1 child. At least 1 means what? Minimum 1 child. Then how you look from the table here? You start from what? 1 child plus 2 children. At least 1 child means you have to go for 1 child. So 51 plus 2 children plus 3 or more. 3 or more means it can be 4 children, 5 children, 10 children. If one family have 10 children, I think it's already enough. Okay. Yeah. So this is the 3 category. You have to add it up. Then you divide by 350. So even B, can you write yourself? Simplify against answer. Any questions? Now, some question can be tested, very difficult one. So this is one simple table I show you. If you have a chance, we can see some of the challenging frequency table which test statistics also, probability. Here is the space you can write. Subjective probability is general probability assigned to an event, okay, based on subjective, or we call it judgment. Now this one can be very biased. You know what's called bias, right? Not fair. Preferences and experience of the person. So for example, you see what we call it bias. You see, in New York, Yankee fans, this is a club, okay, which support baseball. Example, we talk about in America because they are the culture very different one from Asian. See, the people who watch football in UK, right, or they watch baseball in America and so on. Okay, they are very crazy fan one. So these are the club, we call it New York Yankees, which are very supportive of their baseball team. The chance of New York winning the World Series, so we talk about how much the chance of the club can win this World Series. Or there's no absolute mathematical proof behind the answer to the example. So let's say we want to ask this club how much they think that the idol, we call it idol, team can win the World Series. There is no mathematical proof. Of course, who knows who can win, right? A fan might still reply in actual percentage term, say that they have 25% chance of winning the World Series. What does that mean? The club is too maniac really. They are like their favorite team. So even though they cannot prove how much percentage they can win, they still reply, no worry one, this year still can win 25% chances. Is it bias? What's called bias? How you know it's 25? Maybe 10% only, or maybe 1%. So this is bias, subjective probability. So don't let this, we call it judgment. If you don't like the person, what do? You give them low probability, right? If you don't like the person, then you ask how much chances the person can pass. You say maybe 10%. If you think the student are very good, or the person are very good, then you say the chances of that person can do well is 80%. So this is based on judgment, which is not very, I would say that fair. Okay, so subjective probability is very dangerous. That's why we seldom use this judgment. We want to calculate the probability. Okay. Now, let's come to the laws of probability. The first one is complement rule, which I already mentioned just now. PA bar plus PA equal to 1. So to find the PA bar is 1 minus PA. Okay, done. Second rule, take note. Remember the one we have a union? Go back to the wave diagram. This one. This is called union. And how do we write the A union B? Yeah, so are you ready? Look at the rules here. We call this A and B two events defined in the sample space. Probability of either event A, listen carefully, everyone, you can use highlighter, highlight this word, or. When I say the word or, what is the first thing in your mind? Can anyone tell me? Those of you in the stay-at-home now or somewhere can hear me, right? So when you see the word or, what does that mean? Select either one. Select either one. That means cannot be both. Cannot both. Means you either, like example, apple. You can either choose apple or orange really. Cannot both really. So when you have either one only, we use this formula. PA plus PB. And we call this the addition rule. Why? Because it's plus here. Remember, take note of addition means equal plus. So PA or B, we call it either A or B event is PA. probability A plus probability B. And one more thing, rule of addition must be mutually exclusive. Can you highlight this word? What does that mean? Mutually exclusive means cannot happen together. Cannot. I have difficulties here. Can you write down here? Cannot happen together. Picture to see. Now I show you the picture. Can you see the A and B separated? What does that mean? A and B cannot touch at all. Separated totally. It's like a gap here. So it's called mutually exclusive. Can understand that one first. So the event that mutually exclusive means cannot happen at the same time, or they cannot overlap. Meaning they cannot overlap. So you see there's a gap. Now, in general, if I have, this is talking about two events A and B, right? If I have A1, A2, A3, A4, up to AN, I have, let's say, many events. What does that mean? This is how we write. If I have two events only, let's say A or B, I write PA plus PB. In other words, if I PA1 or A2, I write like this, A1 or A2. So I write here, let's say B is A2. So I write here PA1 plus PA2. Am I right? If I have A1 or A2 or A3, how do I write? PA1 plus PA2 plus PA3. If I have PA1, A2 up to AN, this is how we write PA1 plus PA2 up to PAN. One by one, you add it up. That's why we call it addition rule. Clear? Okay. Now, the second condition for addition rule, still addition rule. So that means addition rule got two types. One is mutually. Right down here, I hope everyone can bear with me today. Mutually exclusive here. And another one, non-mutually. So we talked about non-mutually just now, right? Where both events cannot happen together. Okay, so now let's look at the second condition. Mutually means this one. I talked about mutually just now, cannot happen together. Now we talk about second condition, which is non-mutually. What does that mean? Opposite. If mutually means cannot happen together, non-mutually means can happen together, cannot, opposite. So you see here, you write here can happen together. If you want to remind you, or you don't want to get confused, then write here, non-mutually means can happen together. Can you all tell me one example? What are the events can happen both together? Like you do some thinking. Oh, you can see that. Can you tell me what's the event that cannot happen together? Let's go back to this one. Cannot happen together. Gender, boy and girl, cannot happen together, right? Pass or fail. Can a student pass and fail the same subject together? Either pass or fail now. How about play badminton? Either win or lose, cannot happen together, right? So you can see that there are a lot of examples when we do tutorial. You can see some of the events. So everybody, you must do some thinking when when you solve this question later on, you must think whether can happen together or cannot happen together. Now, give me an example can happen together. Anyone? Recently, let's say example only. I think for example, don't quote this. Chinese New Year, some people play for fun. Let's say poker game, right? Poker game. Example only. Probability to get black. You see the poker game, how many shape? 4 shape, right? Everybody play. Okay. And then what are the shape we have? Diamond, love, then the club, right? And the tree, is it? Okay, 4 shape. So if the question says the probability to get black color, 4 for 2 black and 2 red. So let's say probability to get black and also or black means the spade or club. So black, how many? Club, how many? Or both also can, black or club, right? Can happen together one. When you have this scenario, then what do? You must minus back. See the formula, PA or PE. Just now is what? PA plus PB, right? This is the formula. But now you need to take PA plus PB minus PAB. Why we have to minus? Because you see the picture, remember it's A and B. Now, because they can happen together, so they already joined together here. Just now cannot happen together, so there is a split here. No overlap. This one can overlap. That's why you see there's an intersection here. Remember this one, intersection? That belong to A, belong to B. So when you calculate the event for this addition rule, PA plus PB, you need to minus back A and B. Why? Because if you don't minus, you actually count 2 times. PA plus PB. Now remember, because you already combine them here now, if you take PA, you see you take the whole circle, you already count this one time. Then you plus PB, the whole circle. So PB also got this one, right? 2 times already. Is it fair? Not fair, no? You count 2 times already, so you must minus back 1 up here, intersection. If you don't believe, you think this one, probability to get black poker card, how many altogether? You know, 51 red. How many poker card? 13 times 4, right? 52. 52, everybody. So if I take black, how many? Half of it, right? Plus the club one, how many? Each pattern 1, 2, 3, 4, 5, 6, 7, 9, 10, jack, queen, and king, right? Half also 26. Then you must minus back those with the black and the club, which is 1 card. Black and club is only 1, right? Okay, so you must minus back. Otherwise, you double count already. You go and think again, everyone. I use the card. Of course, in this real world, there are so many examples which you see from person in this also. Okay. Right. This is the real example. Now, you all know what's called car loan? That's why I use poker card for easy understanding. Now I'm talking about car loan. Everybody know when you want to buy a car, you borrow from bank, right? That's called car loan. Now, when you go to apply car loan, of course not you all, because you all know. looking at maybe your parents or whatever, or what you can imagine like this. Now, let's say you go to bank and you fill out the form, you want to apply the car loan. Yeah. Now, the bank will tell you, oh, your loan is approved, which means you're very happy now. You get the money already. Or your loan is rejected, which means, sorry, your qualifications is not met. So we have to reject your applications and you can go to other bank and borrow. Now, can I ask you, everybody, when you apply the loan, for example, those of you who apply for PT-PTN one, example, when the PT-PTN say your loan approved, you'll be very happy, right? Pay back 1% interest. But if the PT-PTN say rejected, which means you have to find a way to get money to study, example. But most cases pass, right? PT-PTN, only rejected. So far, 100% approved. Confirm, because I heard there are some. Okay, let's say use the PT-PTN loan, either rejected or approved. Have you ever heard the loan approved and rejected in the same time? What does that mean? Approved and rejected. What does that mean? So yes or no? Can I get the money or no? No, right? This is the one we say cannot happen together. Cannot happen together. It's what mutually exclusive. Like boy or girl, okay, either gender boy, male or female, cannot be happen together. So in this case, yes, explain the answer. Events A and B are actually why. Remember, for this one mutually have exclusive, right? Our PA, you see this one no minus PA and B, right? The formula here, but this one got minus PA and B. So the answer here, can I write here? PA and B, actually, can you tell me what is the answer here? Probability of A intersect B equal to what? Equal to, do you see A and B intersect here? No, right? There's a gap. There's no chances to be overlapped. So if I want to find probability of A intersect B, is it possible? No. So equal to what? 0. Understand that? That's why your formula here, is it? There's no minus PA and B because it's already 0. Why you want to minus? Minus 0 also no different, right? Okay, so you see the formula here, got minus. Because in this case, your probability A intersect B not equal to 0 because there's an intersection here. Can happen together one. So the A intersect B cannot equal, remember this symbol, everyone? Cannot equal to 0. Understand? So that's why I ask you, if the loan rejected or approved, are they mutually? Yes, because A intersect B cannot happen together one. It's definitely null set. Do you know what is this symbol called, everyone? Do you remember what is this? This is called what? Null set, is it? Null set. You go back to your books last time I learned. Okay, null set. Empty set. There's no element because of this. Anyone to understand? Because of that, the probability will be 0. Okay, let's play with some games here. Using example, there are 25 students in one class. 5 of them score A. This is what I mean. Some questions tested using Venn diagram. they write in these long sentences, long story. 10 of them score A. So out of 25 students, 5 score A, 10 score B, but others score C in the QSR. Okay, if a student is selected at random, what's the probability that the student score A or B? Can you tell me, is this mutually or non-mutually? Whenever you answer this type of questions, the first thing, if you know this addition rule, right? Addition rule can be two types. I mentioned it's either mutually or non-mutually. You already know, right, the definition, the difference between them. So can I ask you, 5 students score A, 10 students score B. Others score C. How many score C? 10. How we know 10? Minus only. Okay, now, if a student is selected, what's the probability that the student score A or B? A or B. So you see the word or, right? Which means you either can score A or score B. Any one of you have seen your result, one subject can be A and B together. Funny, right? Cannot happen together, right? Either score A or A, then B or B. So this is what? Mutually exclusive, right? Cannot happen together. So can you tell me what's the answer here? Calculate for me. So now, one more thing, everyone. In answering complete in the right format of probability, usually we define like this, let A, let B, let C, whatever. I'm not sure whether examiner will minus mark or not. If some examiner very strict one, they prefer a person who want to do correctly. You cannot just simply do whatever you like. The proper way to answer probability question is you must define your what's the A and B event, right? Remember event? A is what student score A, B is the student score B. So next step you write PA. This is the probability. Can you tell me what's PA here? You want to draw Venn diagram, can? You can draw Venn diagram, can? But I don't think you need Venn diagram here. PA is 5 over 25, which is 1 over 5. PB then, sorry. Ten over 25. 2 over 5. So what's PA or B? Mutually exclusive. So we have to write PA plus PB. And then, because of the mutually exclusive, right? Do we need to minus? No need, not because A and B cannot happen together. No. The probability must be 0. So is it 2 over 5 plus 1 over 5 is 3 over 5. Make sure your probability cannot be more than 1 now. That's what I mean now. Simple as that. Okay. Usually exam question not the easy one, right? I just want to give you some what we do call that warm-up exercise. Okay, can you try this one and tell me what's the answer here? The answer is here already, actually. But you don't want to see the answer first, everyone don't try to see the answer first. It says that in a college business course, 90% pass statistics, 0.9, 95% pass management, 0.95, and 88% pass both, 0.88. Can be both one, which means, yeah, a student can pass all the subjects, right? Right? So you get 6 subjects, better still pass all the subjects. Try not to fail even one subject also. So in this case, they took two subjects. So 88% pass both. So which is what? Non-mutually. First can pass both. So what's the probability the student pass statistics or management? So we let the T student pass statistics and the event student pass management. And then B, what's the probability that the student pass neither nor? What's the meaning neither nor? Neither nor means both subjects also fail. Pass neither means both also not pass. Okay. Now this is the summary. If you don't want to see this, you do yourself. If you want to see, since it's already here, right? It's okay. PT, pass statistics 0.9, pass management 0.95. This is how you write in symbol. See, whenever you do your tutorial later on, you must learn how to use symbol. It's mentioned in a very long story. Pass both statistics T and N means you use this intersect. Everybody remember this intersect non-mutually can happen together. Pass mathematics and statistics 0.88. So everyone, you must learn how to use symbol. I don't hope to see you write probability, pass, statistics, and management. Wow, long sentence. That's why you must define here. You see, define your symbol. Easier to write in symbol. Okay, everyone. Can you answer these two for me? Then you check the answer here. Now see, the B1, don't pass management and statistics. Is you take 1 minus 0.02 minus 0.08 minus 0.07 minus all. Some of you will get different, use different way, you still can get 0.03. And, if you want to use this method, then you follow here. Remember, this is complement, the bar one. So you take 1 minus, right? Remember? Okay. Finish this. Any question, let me know. So far,
Sir,
I guess.
can you explain A again?
Careful, yes.
How can I find 0.02 and 0.07?
You minus it, from here, 0.88, you see the T is how much? 0.9, right? T is 0.9, this is 0.88, so the balance here is 0.02. How we get 0.02? You ask, right? See, the T is 0.9, agree? 90%. But we know that 0.8 pass the middle. Now, those of you who want to study this Venn diagram, in case any of you have problem, let's look at this Venn diagram. Now, remember the T is the one that pass statistics, right? How many percent? 90%. So right here 0.9, cannot PT. So you see here the whole, you look at the circle of T, circle of T is 0.9. Agree? Okay, next, the middle one, remember this is pass T and M. Remember this is an intercept, both subject pass 88%, 0.88. So you asked me just now, how to get 0.02 for this part? For this part only, T. So you take 0.9 minus 0.88. This part is 0.02. Only this part can hold.
Okay, thank you, sir.
You take this one plus 0.8, you get back the whole T, which is 0.9. Same as this one, 0.95, the whole thing, you minus 0.08. Then this white color one is 0.07. For M only, this part, not the whole M. hope I answer those of you who have problem that. Some of you use other way. I know you can get 0.03. Okay. Now, this is the one. We back to poker card again. Again, this is nothing new. Those of you who play card before, no issue. Those of you who never touch poker card, well, you may need to ask your friend or no need to buy now. Okay, just assume that 52 cards there for each pattern, 2 red, 2 black, and you know the shape. So answer is ace will be drawn. I give you all 1 minute or 2 minutes. Ace is what? What's the ace? A or what? A. King, you know, heart. Ace or king? Is it possible? A and king? Can it be ace and king in the same time? Ace
No.
or heart?
No.
A and a heart. Heart is heart, right? A is A. A can be heart also, huh? But ace and a king can? No, A is A, king is king. Ace and heart can. Because each number got 4 patterns. So be careful. You have to look at whether mutually or unmutually. Right? So you'll do it. This is the answer then. It's the same like if you don't know how many cards, how many patterns there, you can go and take out your card and count and try to identify the pattern there. I don't think anyone don't know. Even small kid now also they know. Okay, so you take a few minutes break. You try to get this answer, and then we shall resume this up. Okay, so can you try that? Resume 5 minutes time.